Recorded live.
Good morning, good afternoon, or good evening, wherever you may be across the nation or around the world. Once again, you're listening to the VMware Community Roundtable podcast. This is podcast number 732. My name is Eric Nielsen, and with me today, I have my regular co-host, Bob Plankers. Today is Wednesday, July 9th, 2025. Bob, how you doing?
You say it's July 9th. I'm wondering where June went at this point, but I'm doing great. It's a decent day out here. I'm in Wisconsin at the moment, somewhere between Wisconsin and Illinois, and yeah, happy to be here. Had a little bit of vacation last week, and that's refreshing. So, yeah.
I gotta say, we're past the July 4th Independence Day holiday in the U.S., so. Always fun to get out and do some barbecue, right? We do live stream on youtube.com/vbarbecue. If you want to see what we look like, you can go check us out. We have a playlist there. We have all our episodes up there. But it was fun. I was down in Florida, out on the ocean, waving American flags and then doing hot dogs and barbecue and having a good time for the U.S. holiday. So now we're all back, and let me tell you, times are accelerating with the VCF 9 launch, behind us, but now all the work goes around talking about all the new features and everything that's going on, and leading up to Explore now, right? We're in the pre-momentum season of Explore. Lots of stuff happening on the show today. We're going to be talking about AI workloads and GPU management. We've got Justin Murray, product marketing engineer for VMware, and Tasha Drew, a director of R&D inside of, I think, VCF. And Tasha can correct me if I'm wrong on that title, but I think that's pretty close. So we're really excited to have, engineering representation on the show today to talk about, GPU management, which I think is a big deal, right? I think so. And for AI workloads. And I think AI workloads are the thing that's, revitalizing the data center, right? Not that it ever really went away, but excited about that. So we'll talk about that, but before we do that, Bob, maybe we should talk a little bit about what's happening in
some news.
Yeah, a little bit of news. We got to do a shout out to Corey Romero for the V Experts. It's Corey's birthday today.
Happy birthday, Corey.
Yep, I hope he's out there having a good time doing what you do on your birthday, which is regretting another year. Wishing you were 29 again, but yeah, he's
like one of those questions. Would you rather have $100 million or be, in high school again with all the knowledge that you have? I don't know.
Yeah, it's hard to say. That's always a good one as you get older. You experience that. Explore 25th through the 28th. If you're not coming, you're making a mistake. There's such good content this year with VCF 9 between the GPU management stuff we're going to talk about, what we have been talking about, the API unification of the management interfaces into operations console. So VCF operations console is all pulling that together. So between GUI consolidation, between GPU management, between the API consolidations, it's just a lot of stuff. And then health monitoring. We talked last week about VCF Health, which was the old
Skyline.
Skyline coming together, rebranded and built right into the product. So just so much tech that we're all going to have to learn as we put together our roadmaps to get to VCF 9. And then, by the way, license management, and they don't actually call it license management. Now we call it entitlement, or I don't remember the phrase for that one, but
people have been calling it license compliance and mixing it up with the regulatory compliance stuff that I do.
Right.
And it's been some very strange conversations at times.
So anyway, great sessions. If you haven't been to vmware.com/explore, go check it out. The content catalog is live today, and they have great filters. Me and a couple of my team members were looking through sessions on each one of these topics, and there are at least 3 or 4 great sessions on each one of these topics for VCF 9 that you can filter down through and look at. And it's just really solid content this year. I was actually impressed by what we were looking at, on each one of these topics. So go check that out. Again, they have different price tiers this year. So if you're on a tight budget, you can get to the show, be part of the community for under $1,000. They went $900 for a community pass to get you in. I've talked about this on other podcasts. Acceptances for sessions. We're still getting some final acceptances out. I think all of them will be out by July 11th. So if you haven't heard whether you got an accepted session or not, by July 11th, a few more days, all the acceptances should be out. So understand that. Schedule Builder goes out July 16th. So if you're interested in getting those sessions, there's always a little bit of a race to get booked so that you have a seat in those sessions. July 16th is the day. Pay attention to that. Shout out to the hackathon. We now have compliance approval for all hackathon invites. So stay tuned if you've signed up for the hackathon. We will be sending out the invites probably this week or next week. We've got your submission. If you haven't registered for the hackathon yet, you can do that. Just go Google Explore Hackathon. You'll get a link to the sign up sheet. We've been socializing that, and go get yourself signed up for the hackathon. It is Monday night. We're going to have a lot of fun. We got pizza. We got T-shirts for everybody. And winners for first, second, and third prize will get Raspberry Pi, which ties into the PowerShell labs we're doing in the Code Lab, where we're going to be running Raspberry Pis with PowerShell, interacting with William Lamb's home lab systems that we've spec'd out. So we got multiple home lab systems with 9 running, full 9 ESX, vSAN, and NSX, along with 9 operations management. So then you'll be able to run PowerShell off your Raspberry Pi and control the 9 systems. So should be a lot of fun, a lot of hacking, and a lot of Code Lab hands-on stuff that we'll be doing at Explore. So if you haven't signed up yet, go convince your manager. We've got letters on all that. And again, we got a lower pricing this year, so go check that out. People's Choice Awards got announced this week. Go look at that. People voted on popular sessions. Those went out this week. We've been promoting those as well. And finally, I'll say, Bob, if you're going to go and you haven't gotten your flights yet, go get your flights, because flights start to book up, right? And
they do book up. But hey, it's Las Vegas, so you can often find some weird flights. Like if I leave from a smaller town just south of me, I can get a flight for like $59 or something like that. And so there's lots of options there. But I would also go ahead.
All right, now we will do a blog on how to do it on a shoestring. So pay attention. If you're really, really desperate, we will put out a blog on what's the cheapest way to get, hopefully we can get it under $1,000. And so we'll see.
That'd be cool. I was going to say too, next week when the schedule builder goes live, if you don't get a session, they do fill up. If you don't get a session that you're interested in, it's not the end of the world. 1, they're recorded, and so you can watch it after the fact. 2, you can sneak in once everyone who's registered gets in. Just stand there for a little bit, and the people will let you in if there's space, and there's often standing room in the back. There's lots of ways, and some of the people guarding the rooms, the room attendants, and that they've got it's a little subjective, but be nice to them, and you catch more flies with honey, sort of thing. You be nice with them, to them, you talk to them a little bit, and they'll let you stand in the back, that sort of thing. So not the end of the world. Worst case, you find the speaker afterwards if you've got a question, and there's lots of us running around. I don't know about Tasha. If Tasha, you're going to be at Explore, I assume. I know Justin is going to be there because he and I are doing a session. But and I just looked. I've got on the video stream here. I've got I searched for AI, and there's about 1,000 different sessions on AI. It seems. Wow. So that's really good. So I might be exaggerating, plus or minus 990 or so, but we'll see.
Yeah, there's some great sessions on VCR operations and how the consoles are all coming together into a single console, right? So that's kind of fun. And if you look at that, there's like 4 or 5 good sessions on each one of these topics, right? And it's like, I could see where maybe I'm not going to VCF 9 this year, but I would definitely show up and start consuming some of these sessions in real time, because there's going to be a lot of great content and great conversations around that that you're going to want to know, right? I'm excited about that. So. All right, with that, let's get on to the show, which I think, one of the major things that's happening in VCF is GPU management, right? So I guess we'll go to Tasha first. Tasha, if you want to, we at Community Podcast will usually ask you, hey, take 2 minutes and tell us who you are from a community perspective. How long you've been at VMware, and how did you get here? Like, are you a computer science graduate? Are you no graduate at all? You worked through the trenches and came up. How long have you been at VMware? What do you do? Give us a 2 or 3 minute elevator pitch of how you got here.
Yeah, I'd love to. So I started here at VMware 7 years ago, which is very easy for me to remember because it was right after the birth of my son. And I came over here because Jared Rosoff, a product management leader here at the time, found me from a bunch of work I was doing at Chef. Chef is a configuration management product, and
Sure.
I was over there originally building their first visibility platform, which turned into their Chef Automate product. But at the time, I was working on an application automation open source framework called Habitat. So Jared had seen all the work I was doing on Habitat and wanted to pitch me on coming and joining the vSphere product management team to put Kubernetes in vSphere. And I'd been doing a lot of work in the Kubernetes community already around application automation. And he kind of nerd sniped me. I got really excited about the idea of Kubernetes in vSphere. And how that could really open it up as a developer platform. So he got me really excited. I never saw myself as a person who would come to VMware. Prior to that, I had been at a bunch of startups focusing on infrastructure platform automation, basically. So I was at Engine Yard, which was one of the first platforms as a service. And then I was at Chef, working on Chef Automate and Habitat. But yeah.
All right.
Can you guys still hear me?
Okay, yeah.
You're
Cool.
You're
doing
fine.
great.
Yep. And I got to say, it brings up memories, Bob. I mean, it's like, before PowerShell, there was just like shell scripting, right? And
I used to build Linux boxes with a make command, basically. Like, I was regarded as a weirdo, but I dabbled in Chef back in the day and landed in Puppet somewhere. We've got Salt. There's some interesting stuff going on there that I can't talk about, but you should come to explore and listen to. And that'll be exciting as well. But and even the DisAStig folks here at in the VCF world, they're still using Chef InSpec to do a lot of the configuration management for the DisAStig work. So all that stuff is really cool, and I think it's underappreciated too. Really,
I cut my teeth in iMake. Right, so not only
iMake, Jesus,
iMake configuration for Make, it makes the make files, right? It's like levels of indirection. But then then the tool business came along, right? And Chef and Puppet and all the other guys and YAML file, editing.
Chef, the era of Chef too was nice because it was, the sort of the beginnings of all this stuff was CF Engine, and CF Engine talked about promises and all of this weird crap that, I didn't want the theory about it. I just want to build a machine, and have it keep itself not screwed up, and so Chef was one of the next wave of things that actually thought that way, and I really liked it. So no, that's very cool.
Right. Well, and so we'll move on. Thank you, Tasha, for giving us a little bit of your career, and we're certainly glad you're here. And now doing GPU stuff. I don't know if that's a step up. I think it's a step up, but maybe other people in the automation world, if you're doing Tanzu and Kubernetes, you could argue that's a horizontal thing, right? But I think it's a GPU management. I'm just excited about the whole space. So, Justin, you're a long time podcast guest. Good to have you back. Give us an elevator pitch. How long have you been here, and what are you working on? And then we'll get into GPU management.
Thanks, Eric, and great to be here. I've been at VMware for 18 plus years now.
Excellent.
I'm old, but I started out on Java, WebLogic, those things, and moved through big data with Hadoop and into GPUs starting in about 2017. My then manager said, get into this GPU machine learning stuff. It's going to happen. And it did happen. So I've been working on NVIDIA related topics, GPUs in particular, and support of GPUs on VMware for about 7 years, I guess, along with private AI and all of the stuff that we built on it. And there used to be 1 or 2 talks at Explore on AI, and nobody came to them when I started. And now there's hundreds of talks on AI. It just shows you what's going on in the industry. It's a hot topic still. And it's nice to be here with you folks.
Great to have you. So Bob, maybe we should try Tasha first and see, how did we get here? Like maybe she knows the product strategy of when we started to really think about GPU management. But maybe you could just start out with like, what is AI workloads and GPU management? Maybe you can just frame it for people that haven't been paying attention.
I think you're muted, Tasha.
Off to unmute. Yeah, definitely.
Cool. Sorry, I keep dropping in and out. So yeah, basically about 3 years ago, 3 VMware Explorers ago, Chris Wolf came out with this announcement about private AI and private AI foundation. And what we had really realized is that as this generative AI sort of explosion took off, that there was going to be a real need for people to be able to leverage all of the power of AI with a privacy-centric model. And that was a really amazing fit for all of the private data center management fundamentals that we already had in place. So we went out and did a number of announcements around what the foundational architecture of private AI should be, both conceptually and then specifically with the VCF product stack. From there, we then launched a VMware Private AI Foundation with NVIDIA product, where we were fully automating the deployment and utilization of the NVIDIA software stack, in addition to vGPU, and how we can start to make it very easy for people to consume, scale, and build GPU-based applications on the VCF platform.
Yeah, that makes sense. It does, Bob. It does remind me a little bit of how we got into Kubernetes as well, right? Where at first Kubernetes was this thing and it was outside, and we're all like, yeah, that's not us. And then we're like, well, maybe we could have a Fusion OS that we do something with. And then somebody, maybe we just run this in vSphere. Maybe this just can be, a prime workload, and then we just build it.
Not to say too much, but it's sort of becoming vSphere too. Like it's all these things are growing together, and that, and I see GPUs in the same way. And what Tasha, what you were saying about the need for privacy, the need to know data sovereignty. All this stuff looks really interesting in the cloud, but then you think about, you're teaching it things that maybe you don't want to teach it, or your own secrets are being used to train it. I just saw something on Twitter or X or whatever we're calling it these days. I think this morning even it was that where somebody was pressing, I think it was Claude actually, pressing Claude for a source for something that it had returned, and it finally regurgitated that it came from the minutes of a board meeting that aren't public, and so being able to run this stuff and do this stuff in a controlled fashion where where everything is, that's super important.
So I don't know. I don't want to. Who wants
Absolutely.
to?
Yeah. Sorry.
No, go ahead.
No, go ahead.
Yeah. So we have 3 sort of pillars of privacy that we think about when we're thinking about AI. We have IP. I have very specific IP that I want to protect to make sure this IP never leaks in a way that could then be exposed to my competitors, or that might break my ability to protect it. Then we have private data. I have data that is regulated, or I have data that's incredibly sensitive, and I want to ensure that I have total protection around it. And then we have models themselves, and model governance is a really hot topic right now, because to your earlier point, a model randomly regurgitate anything it's been trained against, almost word for word in many cases. Even if it's been a long time, you're using a RAG application pattern and attaching different documents to it, it can still just spit out the answer to something it was trained against a long time ago. So you have to treat a model as sensitively as the data on which it was trained, and for that you need a lot of controls around how that model is governed and shared. And we have baked all of that into the Private AI Foundation capability with our model gallery and a number of our other services.
Yeah, that's really cool. And that's I'm sorry. Go ahead, Justin.
Sorry, Bob. I have a buddy who works as a director of AI at a major company, and he calls it the stochastic parrot. So the parrot is listening to everything you're saying and hearing everything you're saying. And stochastically at random, it'll come up with something you said to it yesterday or the day before. Yeah. That's a bit cruel to models, but it's an interesting view from an expert in AI.
Yeah, well, and you don't know their biases either, where the model came from and how it was trained. This discussion came up a lot with the DeepSeek releases. A Chinese model has got different biases than an American model does, for example. One in the US, one of the llamas or whatever, is going to have different answers to things. And, do you like those? Do you like that? Do you not care? Do you not like it? How do you figure that out?
So one of the things I think we're promoting heavily in VMware Private AI is deploy a deep learning VM. It's just a VM that has GPU enablement, and test out this new model that you're interested there in a safe zone, almost a DMZ that's separated from the rest of your enterprise. When you think about that, you can only do that on premises. If you're testing a public model, it's public by definition. What we're saying is, bring open weights or open source models down on premises, put one of them into a deep learning VM, and exercise every tool you can find against it, like the open source GIScard tool for checking for hallucinations, checking for vulnerabilities, checking for bias, like Bob said. Put the model through its paces in this DMZ zone that contains a deep learning VM. We call that an AI workstation. We provision that for you from the automation tool. And once it's tested, as you test any software, then push it up into the model store, the Harbor model store, so that other people can now use it. And that's a kind of fundamental tenet of VMware Private. Sorry,
speaking of tenant and tenant, the multi-tenancy, the idea that somebody can take a vetted model and then deploy it for themselves,
right?
Go ahead, Eric.
It's interesting because I've heard this concept of model contamination, right? Where you're running along, you have your models, and all of a sudden it picks up some data somewhere where you don't want that to have that. How do you back that out? What do you do? And now, companies are stuck, right? Because they put a ton of GPU resource into building their model for the last X number of time cycles, and now they've got some contamination. And did they snapshot it? Do they have the ability to, go back to a previous date? And how do you unmodel? You can't. There is no way to unmodel that I'm aware of. So it's you got to manage, and that's where VMware specializes in managing, bundles of compute technology that you could then snapshot and keep multiple of them and deploy them into sandboxes and secure places and just manage your model deployment. Because boy, the minute you figure out, you start worrying about model contamination, your head starts to hurt, right?
It's just like you're a kid learning a swear word. I compare a lot of the stuff to, we're just inventing children is what it amounts to, and the ability, I'd love to snapshot my 9-year-old sometimes and revert it to before he learned whatever I just said, which I probably shouldn't have said in front of him. But and bringing a lot of that resilience to bear that we've just got in the platform is really cool. Justin, you were going to say something.
So moving back to Tasha, maybe I can ask her what, when we talk about GPU management, is it like CPU management? Are we vMotioning workloads around and then targeting specific, GPUs? And is it similar in concept? Because I look at vMotion, I look at the way we've traditionally run VMs, and I go, does it apply to the GPUs as well?
It does. It does. If I can take this, Tasha, I'll jump in on this one. So we've done a lot of work. There's a whole team on vMotion, as you can imagine, and there's a lot of work being done to make vMotion better and better and better for those large VMs that have a GPU attached to them, a virtual GPU. Virtual GPU is like a virtual CPU. It's a representation in software of the physical device, and that representation in software allows us to treat virtual GPUs the same way we treat virtual CPUs, vMotion that VM from A to B. If you're going to do maintenance on A, and you don't want to stop the job in the process. Now, the difficulty there is that GPUs have memory on board, and they have large memory on board. 80 gigabytes is standard on an H100 GPU, and that's going to get bigger and bigger. In the last couple of years, GPUs have gone from 40 to 80 and higher very quickly. And if you think about now vMotion changing the host on which a VM is running, all of that data has got to get copied, along with the main RAM memory has got to be copied from one place to another. And you don't want to stop the VM while that's happening. You don't want to stun the VM while that copying is happening. So the engineering team said, how much of this data is changing anyway? And when a model is in inference mode, its weights are not changing. So you've trained the model, you've adjusted its weights during the training process, and those are now static. And that makes up 70% of the data that a model occupies on the GPU.
You can copy that ahead of time then.
Exactly. Yeah. So that's called the pre-copy phase, where you say, I'm going to copy, I'm going to copy, I'm going to copy all of that static data ahead of any interruption, if you like, any stun of the VM. And so only 1/3 or 30% of the data is actually dynamic. That's called the KV cache, key value cache. And that's changing because different words are coming into the model to say, do you know anything that sounds like vSphere and GPUs? And that's where that dynamic data is coming from. Only that data is copied during the stun time. So for a 48 gigabyte GPU like an L40, roughly 1.8 seconds to vMotion that from one place to another to stun that, during the vMotion process. The application is not going to notice that. If you go enormous on me and say, I have 8 GPUs assigned to my VM and each of them has 80 gigabytes, that's 640 gigabytes of data, we'll stun for about 20 seconds, which to me is
that's still absolutely awesome, man, because you've turned this into anytime you're attached directly to hardware, that becomes an operational issue for patching and other maintenance things or whatever. 20 seconds is not that big of a deal.
Right. And that came down from well into the hundreds of seconds in 9.0, which is pretty incredible. What it means is vMotion is not going to time out, even with the biggest thing you can throw at it. An eight H100 GPUs attached to one VM. vMotion that for me from one host to another. I challenge any other company in the world to do that. Nobody's doing that apart from us. And as you said, Bob, the reason for doing it is moving the VM away from a place where you're doing maintenance or doing a fast suspend resume because you needed to add some more devices to that VM.
Yep.
So that's really in the infrastructure. You get that for free with VCF 9. It's one of a series of things that have hugely improved in VCF 9, in my opinion.
Well, and what you're talking about here, to your point, is actually built into the core of everything. It's been part of vSphere. It's deep in ESX. It's all of that stuff. And so that's there's a lot of work there, and that's really cool. And it really just makes these workloads, AI, and I'm sure AI folks like to feel that they're special. We all want to be special. But from an infrastructure operations perspective, we don't like special. Special is bad, and when it can just be treated like another workload, awesome.
We want to make this just like any other workload in the data center. It's not quite the same. There are these GPU devices involved, but that's the objective exactly, Bob, is to make it just another workload that people manage in the data center with the same tools: VCF operation, VCF automation, vCenter. Yeah.
Tasha, and I don't know if this is a question for you, but I'll hit you with another one. When we're talking inference versus training, right? When you guys are looking at your product and your product roadmap, how much are you just focused on inference? Which for me, I call it runtime in case people are very savvy around AI. Inference is just when you're running the model versus training the model. And then also, it seems like we're also focusing on the models themselves and what models are good for our environments, right? And I don't know if you spend time worrying about just the cards, whether it's NVIDIA or weather, or whether you're up the stack for the models themselves, and then how much is inference runtime versus how much is training. So maybe you could give us some perspective on that from a product management perspective.
Yeah, absolutely. So the focus of the product is definitely inference. For training, really hardcore training, you're going to go probably bare metal and just be hammering the GPUs at their maximum usage. And there's not going to be a lot of opportunity to get benefits from virtualization in those use cases. However, there's a lot of data that's been coming out showing that when it comes to inference, there's a lot of underutilization of GPU resources, which is really kind of mind-blowing because GPUs are really expensive. GPUs are really hard to get. And so now we're actually procuring them, we're getting them up and running our inference workloads, and then we're underutilizing them. So there's a lot of opportunity to really improve your ROI on that infrastructure by going into a unified platform approach. To the second part of your question, we are introducing a number of platform capabilities in VCF 9.0 with Private AI Foundation to go further up the stack and help people start to run their models as a service. So not every team needs their own GPU running their own copy of Llama in order to use Llama, right? Like that's really an inefficient utilization of your GPUs. If as IT, I can very easily go in and spin up a model runtime API, and then behind that start running one GPU with Llama, and then give access to different teams and different people to my copy of Llama on that GPU, get all of the utilization metrics I need to see, hey, like this is really highly utilized. I can easily horizontally scale this by adding another copy of Llama. Suddenly, I can provide as an IT team Llama as a service to my organization in a very cost-efficient, resource-efficient way. These are all of the things that we're baking into the product to make that easy to do.
Yeah, it seems like we're in a little bit of a gold rush time right now where AI shows up. So your engineering teams, your product teams in your corporation goes, oh, I need GPUs. I need GPUs now. I got to get them. Because you don't want to, you're already behind, right? And so you order a bunch of GPUs and you set it up in racks. And then you're like, oh, where's the engineers? What am I doing? And all of a sudden, and every other department is also doing that. And so you get this flood of GPU ordering. And now you got racks of GPUs and you're looking at them like we did in the CPU days where you had a 10% utilized in the rack. And you're like, wait, if I can virtualize this stuff, I can get a 10 to 1P to physical to virtual conversion. And it's just better to management. And honestly, everybody that's paying for these things are kind of happy because they get out of, they can put it in a pool and say, oh, I didn't accidentally spend 20 million on all this hardware for nothing. We can actually use it other places, right? And I think that's a win for everybody.
And there's second and third order costs too, and people forget about that. Like these GPUs. I mean, who is it? Microsoft that bought a nuclear power plant to run their GPU data center, and which I think is cool. I'd love to have a nuclear reactor out back in my house, but that's just me, I guess. But these things, they take a lot of power. You look at the power supplies. You try to buy a Dell with a GPU enabled Dell that you can stick. Well, even one of the NVIDIA, what are they? The HGXs or whatever that you can put the 8 GPUs on or whatever, and it needs 10,000 watts of power, and that all is getting converted to heat. So, there's a thing where there's a measurement of data centers where basically how many for each watt that goes in, how many watts of power you need to take the heat back out again too. That doesn't just disappear on its own. And all that stuff adds up, and it limits where you can put these things. You can't just plug them in your home office or whatever. That it needs 208 volt, 240 volt power and all that stuff. And so anytime you can make the beginnings of this stuff more efficient, you make the whole thing more efficient.
And another reason for inference, as you asked, Eric, is that to do training of a foundation model, you need 1,000 GPUs. And imagine what the effects of that are on your power consumption, your heating. very few enterprises that we come across have 1,000 GPUs. They have 40 or 50 or 60 GPUs.
Right.
So those enterprises are going to be more interested in inference based on models that have been pre-trained by somebody else. It's a highly risky process to do training of a model. You may come up with a model.
That's what maybe Tasha meant by climbing up the stack and choosing models that are enterprise safe, that then maybe you do some RAG or augmentation of the data, right? But basically you're picking a model and you're gonna deploy that model, and it's a known model, you're not training, and then you might be augmenting it, and then it's all inference, right?
Exactly. That's the core target for us to begin with, is deploy retrieval augmented generation, the database complementing the model, where the database has the private data. The model doesn't have the private data to begin with.
Right.
Private data has been indexed and embeddings created out of it, and it's been stored in a vector database that we want to nail down. We want to secure that with RBAC, with encryption, with access control, with all the things that you would do with important data in your enterprise. And then when a question comes in a chatbot application, that question is fed to the vector database first, and the results are given to the model as the truth, the source of truth. That's the retrieval.
What are the enterprise models that are out there? We've got obviously Google Gemini, Facebook, and Llama, and OpenAI with their open. I don't even know what they name their OpenAI models these days.
I don't think they do either.
The big three. Are there any others, smaller ones? But
Yeah.
you're going to choose one of those three, right? To deploy in your enterprise, I would assume.
The first
not necessarily. Yeah, sorry, not necessarily. So I think everyone is really excited about the larger LLMs. But the interesting thing is, you can get in a lot of use cases, you're going to want to get a more specific model to exactly what you're trying to do. That model will be smaller, and that model will give you better results per use case. So these larger, more generic models are really, really good at interacting with you like a person and being able to answer things across a whole host of different use cases and different topics. But then if you want to get super deep into supply chain management for my tire factory, you're really going to want a model that's focused on supply chain management for a factory, and then maybe fine tune it against your own operational data. Yeah.
So are there vendors that are doing that, like going into, like, just like my accounting system specialized in wholesale operations, and you got all kind of the software services that are specialized by industry. So AI services or AI models might show up per industry. Is that starting to happen?
Yes. Yeah. And Hugging Face is sort of the GitHub of the machine learning world, and it has thousands of models on it that are being that are being provided for folks to use with different terms of service. Obviously, you would want to really validate any model that you bring into your enterprise, and we have a number of blogs and content giving people a really nice enterprise workflow for how to validate, security scan, and make sure that a model is up to your own corporate governance standard before you bring it in-house, kind of reflecting on what Justin was talking about earlier with regards to model governance. But there's a lot out there. There's a lot of academic folks, a lot of researchers providing their work, and there's a ton you can start with for sure.
And even we hear about country-specific models that are good at Japanese or Korean, or, there's a whole bunch of specializations, as you indicated, Eric, going on.
I was on a call the other night that was doing active translation between one of our coworkers, Justin, and Korean, and active translation to Japanese, which was wild. Like, it's gotten so good. And there's I'm on the YouTube stream, and I'm sorry, Justin, you were going to say something. Or maybe it was Eric. I'm just pointing out on the YouTube stream, I've got the. To Tasha's point, that there's all of these different types and specialty models here. I've gone to Hugging Face and just expanded the type of tasks here. There's 50, 60 different categories of tasks, whether you want to do text to speech or audio, video, all of this stuff. My goodness.
Yeah, it's huge. Organizations as diverse as Mistral, a French company producing the Instruct models, or the Dubai Institute for AI Research is producing models called Falcon. The Beijing Institute for AI is producing BGE models, especially tuned for embeddings for dealing with the data going into a vector database. I totally agree with what Tasha is saying. They're going to be smaller, fine-tuned, industry-specific, application-specific models for your doctor to listen to what you're saying in the interview and writing the doctor's notes at the end. That happened to me recently. And, lawyers models that will understand legal data. All of that is coming.
Well, then you can chain them together too. I'm sorry, Eric. Go ahead.
Some of my best questions are the ones where I'm absolutely wrong, right? Where I go, yeah, aren't there only like 3 or 4 models? And Tasha lights up, Justin lights up.
Yeah. Right. So,
there are 4 famous ones.
Being wrong is the beginning of knowledge, right? So
right. I was 0 days old when today days old when I learned that there are all the specialty models. I'd heard of Hugging Face.
Hugging Face, yes.
Hugging Face with the models there. But that just means that, yeah, you're going to need more VMs, more GPU management where, if you start having industry and inside a big company, you might have different models running for different pieces inside the company, right? So, yeah.
Well, and chaining them together. Like I use a model locally here for transcription. So when I do a video for YouTube's video translation, I don't like it at all. And so I do my own thing here and I use a model called Whisper, but then I can take that video. Sometimes I'll take videos and feed them to Whisper and then get a transcript that I can actually feed to another model to summarize, and so.
Yeah, there are models for evaluating your system that, given that you built an AI system with a couple of models in it, like Bob has done, there are models that will evaluate that and throw traffic at it to make sure that it's
interesting.
Yeah. So it's going to spread. It's going to get larger and larger, the world of models. And with that in front of you as a data scientist, you're going to say, where's my test platform where I test this out? And how do I repeatably test my model to make sure it's not got any disturbance or perturbation, as they call it? How do I test this in a repeatable way? VMs are clearly the way to do that. It's
using all of the stuff that we've been using since 2005, man. Like snapshots and all of this stuff can be brought to bear on this new problem. Turns out, now that especially given vMotion and all that stuff, again, it just looks like variations on a theme, and that theme is 40 years old.
It seems even more relevant than the web Apache, web services apps, which were important, but you could manage them other ways. But for me, this feels like the expense of GPU is such that you're just not buying 1U servers and stick them in a rack and, oh, look, I got too many 1U servers, let me use VMware to consolidate them. This is like GPUs are so expensive that you better just start this way. You're not going to be able to afford it unless you do manage your GPU resources more effectively.
Another GPU management thing that we've just invested in is the capability to use these things called direct path profiles. These are a mechanism for you to see which virtual GPUs are using the physical, and how full is my physical GPU if I'm sharing it across 2 or more tenants. And speaking of tenants, there's a capability to say, I promised 1 full GPU to Bob and I promised another full GPU to Justin. Can I guarantee that they get the GPU when they come to use it? Can I absolutely give them a reservation at the restaurant such that their table is empty until they show up? And GPU reservations is another addition to VCF 9, which says, if you're in the multi-tenant world, you could be in the multi-tenant world within Broadcom with 26 business units. I'm going to allocate 20 of my GPUs to VCF and 10 to Tanzu business units. And I want to guarantee that they get those when they come to use them. That's the concept of GPU reservation, another GPU management idea that we've come up with.
Very cool.
Nice.
Yeah, well, go ahead.
No, I was saying
Okay.
nice, but go ahead. I want to do time management. I got to make sure that Tasha, we're coming up to the top of the hour, and if Tasha has a 1 o'clock, I want to make sure that we wrap up in time for her, or we can go a little long depending on where we all sit from a calendar perspective. So as we come up to near the top of the hour, I'll just ask Tasha, are you on a hard stop? If you are, then I'll take you through my questions I give people near the end of the show.
Yeah, I can hang out for a little bit. Happy to answer more questions.
Cool.
All right, great. Bob, you were saying.
Oh, I was just gonna. I'm still. I like what we've done. We've put a lot of effort into GPUs and all of that stuff. Like Tasha, I joined about 7 years ago, VMware as well, and we were just starting to look at a lot of this development was just in its early forms, like how do we pass a GPU through to a workload? How do we manage that sort of thing? And just seeing where it's gone, and also watching the space too, like just thinking about, well, I'm thinking about what Justin and I want to talk about in our explore session. Some of the challenges, most of the challenges tend not to be technical ones, like we've talked mostly about people and process things here, how do we use technology to deal with stuff, but even politics too, the ability to back up everything that a data scientist has built and then vMotion it or move it somewhere else, move it to a non-extradition country somewhere, or because politics, people are trying to ban AI and things, and I don't think that's going to work on a personal level, but given how open the technology is, but but even from a disaster perspective, and that these are things that you can retain your data sovereignty and all of that stuff and get these reliability features and these resilience features too. And so
yeah, sovereign AI is huge for us, because a lot of countries are thinking very hard. They want their AI to run within their borders. They want their data, their citizens' data, to stay within their borders, but they want the benefits of AI. They don't want to fall behind technologically. And so, yeah, that's been a huge use case for us with service providers globally, and we see it only continuing to grow.
Yeah, the concept of data gravity, that term that came up many years ago at this point, like you got to feed these things, these models, especially to train them. And I know we're talking more about inference, but even the RAG databases, the retrieval augmented generation stuff, you got to put these things where your data is. And the interconnects there, all of our interconnects, that's actually one of the coolest things about being part of Broadcom now is, watching the networking development that goes on in our other divisions and things, terabit links or whatever, just crazy speeds.
Well, and Bob and maybe Justin, you can chime in here. Like, I think there has been an issue around AI and data security in general. AIs want to train; they want to go out and steal as much data as they possibly can.
Well, the cloud ones do, they want to learn and be better, right?
And I can see Sovereign being like, hey, it's our data. We want to monetize this data, and data is a monetization capable, offering. And so if you just let the Googles of the world come in and grab your data, they're going to grab it and they're going to stick it in their engine, and you're going to lose the monetization options. So sovereignty makes a lot of sense here.
But there's a flip side to that too. And Tasha, you talked about IP, intellectual property, early on here as a big reason why what we're doing is really interesting to a lot of folks. And but that goes both ways. I don't want my IP to leak out to the world, but I also want to know what IP, and this goes to model testing and things like that, the provenance of what these models know. Some of it's copyrighted data. And like Meta, the Llama models have been trained on pirated books. How's that going to work? And the legal side of things, the legalities of that stuff haven't been sorted out. And so getting that under control and having access control on who can find out about that too. I'm sorry, go ahead, Tasha.
And two funny things. One is I read in the news a week or two ago that a judge had ruled that it was okay to train your model on a book as long as you'd actually bought a copy of the book. But of course,
I think I read
most of
that same
the
thing.
hyperscalers, yeah, most of the hyperscalers, it turned out, did not buy copies of their book. And then the other thing is that the making sure that the model you're using to generate something, if that something is critical IP to your organization, that model needs to have been trained in a way that is very, very safe legally for you. And right now, a lot of the popular code generation models that are hosted by hyperscalers were not trained against permissively licensed open source code, which means that they are generating code that is protected by copyright in many cases, to the point that GitHub, Microsoft have had to come out and promise to protect customers in court if they are accused of copyright infringement as a result. And, there are, however, very well-trained coding generation models. For example, Hugging Face has StarCoder. And so you want to be so careful when you select the tool you use to make sure that it was trained against data that's not going to get you into legal trouble, basically.
I'm chuckling here because I just renewed my GitHub subscription, and I've got Copilot attached to it. And there was a thing about that right there that indemnification against not that I'm releasing a ton of code or anything like that, but yeah, that's a big deal.
And just to contribute some more, at the tail end of the pipeline, you've got an answer from your chatbot about a sensitive subject inside your company, whatever that might be. Where did the answer come from? Like
reproducibility. Yeah.
How did we qualify this person for the mortgage loan? Why did you give me a decision, yes or no? What documents did you use to support that? The ability to quote where your data came from to make a decision is something we deliberately built into private AI to be able to see the references from the vector database that said, it's okay, Justin earns this amount of money, give him a loan, or it's not okay. That sort of reference documentation that's important to show a regulator, somebody who would be concerned with sovereign AI, for example, that we actually used a UK document to give a UK answer. We didn't use the USA document to do it. That would be vitally important to keep the regulators happy. And that's a feature that we support.
I was not aware of that feature, and that is super cool because, even just reproducibility. People talk about that code example that Tasha, you were talking about. You vibe code something, and then you want something changed. Hey, AI, can you change my thing to improve it? And you won't get the same answer twice, And so being able to figure out where that answer came from and how it got there, really important.
All right. We've been streaming for 51 minutes, so we're going to transition to the last section of the podcast, which I always so I'm going to ask Tasha. We'll see what I normally say what excites you and what keeps you up at night, but you know what? AI is so exciting. I'm not even going to bother with that.
And it should keep you up at night too. We've all seen Terminator, I'm sure.
What does keep you up other than us inviting you to a podcast where the firewall blocks your camera view on your laptop, so you have to do it on a phone? Other than that, what else keeps you up at night?
Oh man, great question. I think what keeps me up at night is thinking about how fast this ecosystem is moving and making sure my team is building everything in a way that we can consume and contribute to that ecosystem in the fastest, most efficient way possible so that we keep up, right? And that our customers keep up. And I think we've done a really good job of that, but you just have to constantly stay on top of where's the technology going, what's the latest trend, where is this, and then make sure that we are enabling all of our customers to keep up too.
Yeah, it is moving insanely fast. I can see where if I were trying to build product these days, it would keep me up at night, right? Yeah, no question about that. Justin Murray, me and you've been here for 20 years. I'll tell you what keeps me up at night. Too much spicy barbecue, an hour before bed. That's what keeps me up at night. But I don't know
that way too. Don't worry.
Justin, what keeps you up at night and as far as the industry goes?
Reading AI papers about KV cache late at night is very bad for me. I know that, but
does that keep you awake or is that a sleep aid?
It depends. I think, we're producing wonderful technology to support AI. And what worries me a little bit is, am I presenting the thing that's most useful first to our field? Part of my job is getting our field up to speed on this, getting our customers up to speed on this. And the tiniest little innovation, like visibility to virtual GPUs, that hasn't been there before, could be the most important thing. I worry about what's the most important thing to show first. As you heard me, we have a whole palette of things to show. We have a lot of contributions to AI here, but I want to find the thing that hits best with the audience, and do that first. That's the kind of thing that bothers me.
Yeah, I could definitely see where, there is a responsibility, right? And we want to enable people and help them. And we're community people. And you've been on this podcast a bunch, so you definitely bring that to the table, right? Which is a caring and wanting to get information out. And that's why I got into community to begin with, is that I'm stupid and I need to be able to read what everybody else writes about so that I can learn it, right? I don't have to do it myself. But Justin and Tasha, thanks for coming on the show. Last minute of the last 5 minutes is
we're missing a question here.
How do people follow you? Where do they read more about what's actually happening? Tasha, you're an engineering manager. You might not even be on social media. I don't know. That's okay.
I'm on LinkedIn. So I'm just Tasha Drew on LinkedIn. But that's really my main socials these days. And we post a bunch of blogs. We have a ton of resources. And if anyone ever is wondering about anything, feel free to DM me. I'm happy to answer. Yeah.
All right. So Tasha Drew, TASHA DREW. So you can find her on LinkedIn and try to follow her and see if she'll follow you back. Right.
And there are two Justin Murrays on LinkedIn. One's a football player, and that's clearly not me.
Not you.
But I'm the other one. I'm JOH Justin Murray on LinkedIn and Twitter and X. And I'll be there at Explore. Come and see our talks. I'm doing a joint one with Bob that should be interesting. And
a lot of this stuff. Yeah.
We'll be around the booth as well. We'd be delighted to see you there. But ping us offline as well about questions on this stuff. We'd love to hear from you.
This stuff is red hot. If you're not at Explore, you're making a mistake. VCF 9's got this, and it's just gonna get redder and hotter. So get early, get involved, because I personally think I've heard quotes that we're doing more deals now than we did back in 2011 when we would just used to take orders for virtualization, right? Like that this is now brought the data center back to where it was back in 2010-11, where everybody just goes, yeah, we're doing this. This is a no-brainer. And so if you're not up to speed on the APIs, there's a great session on GPU management with APIs, PowerShell. You can go sit through that. We will be publishing, I think, 4 or 5 great sessions on at Explore on GPU management. So I think we've identified those, and watch for social on that. We're also shout out to the session from sorry, I'm on the wrong spot. Tony Foster has got one on scripting GPUs, so pay attention to him and look for his session. And go register for VMworld. So finally, barbecue. We do stream on youtube.com/vbarbecue. So Tasha, you obviously live in Northern California here because you're on campus dealing with the Broadcom Wi-Fi switches. Do you ever do any barbecue? Do you buy barbecue? Do you go to barbecue? Give us a 1-minute barbecue report from Tasha.
If you're going to roast something over an open flame, what would it be?
Yeah, we are fortunate enough to have a really nice deck with a little barbecue on it. And so what we really like to do is just take chicken thighs and then kind of make our own Italian dressing, olive oil, salt and pepper, some herbs, marinate it, and then just throw it on, and it's delicious and easy. So if we have a crowd coming over, that's normally our go-to.
That's awesome. That sounds delicious. I also didn't have any lunch, so I'm pretty much just getting hungry with whatever you say. So.
Justin, I forget what you've told us 15 other times, but we'll hit you again.
Yeah, if you want barbecue right now, what would you do?
The one thing I'm half decent at on the barbecue, I was taught by my wife to do this, is ginger on salmon, teriyaki sauce, and a little bit of ginger on a salmon steak. A couple of those on a Sunday night. The neighbors to the left are doing theirs, the neighbors to the right are doing theirs, and I'm in the middle pretending that I can barbecue. But it turns out okay. It turns out that's my favorite thing.
That's nice. I went 4th of July. I was down in Miami with my nephew, and he does beef ribs. And oh my gosh, it's like doing what are the ones you'd like to do, Bob? The when
like
you're not
brisket or whatever.
He does it like a brisket, right? It's a 12-hour smoke.
It's a process, yeah. It's not like the 3-2-1 for the pork ribs or whatever. Yeah.
He keeps it to a temperature and then stalls it, and the fat does its thing, and oh my gosh, it's like it looks like a brisket at the end, right? Beef ribs.
Excellent. Yeah, I should try some of those sometime. I've got 2 pork butts. I'm going to be on vacation here in 2 weeks. And it's my wife's family's gathering in the Lake of the Ozarks area in Missouri. And one night, we all take a night to make dinner for 25 people. So I've got 2 pork butts that I'm going to throw on there and take down there in a cooler. So
can't go wrong with that. I am actually going to do Korean barbecue outside. I'm taking steak and chicken, slicing it really thin, and putting it in Korean teriyaki sauce and letting it marinate for 4 hours, and then we have a little Korean barbecue that we put outside and lay that stuff on with some rice and asparagus and squash, thin squash slice. So
I'm hungry, Eric, and we're not going to get any lunch today.
Yeah, exactly. Right. Have fun, everybody in California that missed your lunch. We appreciate you coming on the community podcast.
Yeah, very much so. Good to see you, Tasha. Good to see you, Justin.
Thanks for having us.
We'll be back again next week. Until then, go get some barbecue and have a great day.
Thank you. Take care. Bye.